Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will help explain the necessity for cleaning and inspection of fiber optic components and equipment, show some of the accessories and devices used for cleaning and inspection, and will demonstrate the proper procedure for cleaning fiber connectors and optical ports. Most technicians, if not all, will agree that keeping connector ports and end faces clean and free from debris is one of the most important and underutilized aspects of fiber optics. Proper maintenance of fiber connections is always highly recommended. A deeper look into some important facts about cleaning will provide insight into why this is true. Fact number 1. Clean fiber optic connections provide reliable test results. A completely clean connection eliminates uncertainty from test results caused by debris, so the link passes or fails based on the quality of the link alone. Dirty connections, on the other hand, introduce additional loss that has nothing to do with the true quality of the link. In fact, a dirty connection could cause a link to fail, even though everything else was done perfectly. In this way, links tested with dirty connections are to be considered unreliable. Fact number 2. Clean equipment ports provide assurance that equipment factory calibration levels are maintained. If debris is allowed to build up in equipment optical ports, the equipment will appear to be out of calibration and may cause an unnecessary trip to the calibration facility. Worse yet, if calibration levels are not checked regularly, the tester could be producing inaccurate test results and the technician may not even know it. In addition, some customers will not pay for services if the test equipment was found to be out of calibration. Fact number 3. Most importantly, properly maintained equipment ports will prevent costly equipment repairs. If too much debris accumulates in optical ports, repeated connector insertions may grind the debris into the equipment's internal optical components. This damage cannot be fixed in the field, and the equipment must be sent back to the manufacturer to have the parts replaced. This is especially true for OTDRs and laser sources, which could cost several $100s to repair. So why is it that very few technicians actually integrate proper cleaning and inspection practices into their everyday fiber testing regimen? Some may be skeptical of these facts and do not take the warning seriously. Some do not want to take the extra time to do a proper cleaning, and still others do not want to keep proper cleaning supplies immediately at hand. Whatever the reason, there are serious consequences if fiber optic connections and optical ports are not maintained properly, especially in fiber optic links where life safety is a major concern. In fact, the fiber optics industry believes that cleaning and inspection is important enough to develop fiber end face quality standards such as the IEC 61300-3-35. There are two types of components where technicians will focus their cleaning and inspection efforts: end faces and ports. An end face is the tip of a fiber connector, while a port is inside a patch panel or equipment port. Connectors insert into ports, so there is a good chance that if one of these components is dirty, debris will transfer onto the other during insertion. Thus, it doesn't help to clean just the connector or just the port. Both need to be cleaned and inspected to ensure a quality connection. However, it should be obvious that a device that can clean a connector end face would not be able to clean inside a port. Okay, first I'd like to cover some end face cleaning and inspection accessories. So what we have here is a fiber inspection scope, which this is called a direct view fiber scope. And we also have a fiber end face cleaner. Now, we'll start with the cleaning aspect of this topic. When we have an end face, like a connector, like this, like a patch cable, we want to make sure that the end face is clean. So we use this end face cleaner and maybe rub a few figure eights on it until we feel it's clean. And then we use this direct view scope. We plug into the adapter. We look in the viewfinder here, and then we turn the end face viewer focus wheel until the end face comes into focus. And then we see if there's any dust or dirt. If there is any dust or dirt after cleaning, you simply clean it again. And inspect again until the end face is clean. Now, one note about direct view fiber scopes like this. Okay, they're called direct view for a reason. This is because the light coming into the port is being directly viewed by the eye through a series of lenses. So any light coming into this port is being magnified into the human eye in here. Now, since fiber optic light is largely invisible, you wouldn't know that a very bright amount of light is coming into your eye and your eye could get damaged. Now, these scopes do have some sort of optical filtering to prevent some of the light from coming in, but the safest thing to do is to make sure that whenever you use a direct view scope, make sure that the other end is disconnected from any active equipment. This will go a long way in protecting your eye from injury. Okay, now let's move on to in-adapter cleaning and inspection accessories, starting with the cleaning accessories first. But I think one of the main things we need to understand here before we continue is that there are two different ferrule diameters in the industry. There's 2.5 millimeter, which is your SC, ST, and FC connectors. And there's also LC, which is 1.25 millimeter. So obviously, if we're cleaning inside an adapter, and we have a cleaner for 2.5 millimeter, we can't clean our LC with that because the ferrule diameter is just different. It won't be able to work. So you have to have a cleaner and an inspection accessory for each of the different ferrule diameters that you need to test. Now, first of all, I'd like to demonstrate the cleaning accessories that you would use and some examples of what you can clean. So first of all, we have a patch panel we could clean. We have a light source port like this one that we can use to, a cleaner with, or we can clean OTDR ports. Notice that there are different ferrule diameters here. There's an SC and an LC. So we will use different cleaners for those. So we'll use a 2.5 millimeter cleaner like this one, and these are called one-click cleaners for a reason. So we would just plug into our patch panel, one click to clean. Or if we're cleaning our light source, one click to clean. Or if we're using LC, we use our 1.25 millimeter cleaner. Again, one click. It's very convenient. But just because we've cleaned these adapters doesn't mean that they are necessarily clean. This is where we inspect the adapters. And we use what's called a probe microscope for this. Now, there are different types of probe microscopes where there might be a handheld monitor where you can see the end face in the field, or you can attach the probe to a USB port on your computer, for example. But the main thing is you need a probe like this to get inside of the adapter. So here's how this works with a patch panel. You simply plug into the patch panel. You will wait for the end face image to appear on the screen, and then you can use the focus wheel to focus. The nice thing about probe microscopes is that you can also capture the end face images for later analysis. Likewise, we can use the 2.5 millimeter tip here for SC. We can clean inside our light source. However, this won't work with LC. So most of these probe microscopes come with removable tips. We simply remove the SC tip and we put the LC tip on. Once we have that attached, now we can plug into our LC port again, we wait for the end face image, and then we can simply use the focus wheel and focus the image. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more instructional videos, or to learn more about OWL's products in general, please visit owl-inc.com. I'm Professor Jim Powers. Thanks for watching.